We have discussed a lot about the LangGraph and Langchain framework. Similar products are available in the market like Astra and any other products. These all products are having inbuilt GUI console where you can just drag and drop your necessary modules. Even LangGraph Enterprise version is having similar features. However, we are always dealing with the open source framework and we need to leverage it to a GUI console. How do we achieve it? We have three options in place. If you are using MacBook, you have a LangGraph Studio that is pretty straightforward. A suite, you need to install it, log in, and just perform the transaction. If you don't have MacBook, the next option, last couple of weeks back, or precisely speaking, March 17th, Langchain community has released a product called Langchain Builder. Using the Langchain Builder, you don't even require any login credentials. You can create your own workflows and later you can embed the necessary nodes and the logics within the workflow diagram. Additionally, the x86 architecture also supports this LangGraph Studio, but a lot of bugs are being reported from the community and a lot of discussions are ongoing. So I would recommend either you may use LangGraph Builder, which is a SaaS solution, completely free. You don't need any username and password. We have already done a video in our previous segment. Or you may use LangGraph Studio on top of MacBook. In this segment, we are going to create a LangGraph workflow with the help of LangGraph Studio. Without wasting much time, let's move on to the workshop, and this is Melvin Satishan. First of all, let us open the GitHub and create a repository for saving our code. It is going to be NGDM, Next Generation Delivery Model. The repository contains all the LangGraph Studio codes. I'm going to make it as private and I'll add a readme.md file for later documentation purpose, and it will be under GNU public license, and I'm pretty happy to share this code among us. Then we are going to clone this repository. For that, we have to open a VS Code and clone a GitHub repository and clone from GitHub, and we'll go to NGDM, and in our desktop, engineering, workshops, git repo, and here we will open the NGDM. Okay, it has been cloned here, well and good. Next, we are going to create a directory structure within it. Let's see, here it is NGDM. Under NGDM, we have to create a small folder called project folder, I would say. Alpha, any name you can provide it, perfect. Inside alpha, we will have to create another folder called utils. This is basically a directory structure that is being followed by the LangGraph documentation, especially the NGDM and alpha that I have given my project name, whereas they have provided certain naming examples, right? And inside this utils, we have to create a few files. The first one is going to be init.py. The Python special file. The second file that we need to create is tools.py, and then we need to create nodes.py, and finally state.py. Okay, so inside the utilities we have a initialization, then node functions, state functions, and tools functions. We are arranging it in a professional manner, nothing more, nothing less. And under alpha, we have to create another file called agent.py. So in this, our agent codes will be defining, and we have one more thing because we are running everything on top of Python. So here we have a requirements.txt. Okay, next we have the alpha part. Then finally we have to create our environment variables. So for that, .env, if you have any global environments, that you can define it in this, but the problem is alpha ngdm, right? So it should be in the parent folder because we are going to run the project from here, ngdm. So it should be here so that we can consume the load.env function. And finally we have to create our metadata file that's called Langgraph.json. This is basically our metadata. We will define everything. Let us start by defining the LangGraph environment variables. We are going to define base_url equal to http://localhost:11434. This is our LLM base URL. Model equal llama 3.2:3 billion. So we have this two parameters in place. Well, next part we need to define the parameters inside the utils, right? So let's define the tools first. In the tools, first we are going to define node_a, which is going to take a state, and here we will mention input_node_a, which is supposed to provide the output_node_a. So this is what is gonna happen. Here we will write print fstring, the state of the node a is state. Okay, and in this case we need a couple more parameters. So let us mention here output equal to, here we need to define name. The name we are going to define again state name, and here we are going to define profession, that I'm going to define, let's say IT. Okay, so our response is ready. Return output. So our first function is ready. Then we are going to create the next function. Here we will define node B, and here we are going to define node B. Rather than node B, we will mention here output of node A will be the input of node B, and output of node B will be the output of node B. And here we will mention node B is, here we have defined state, name, profession, IT, and we will add one more thing, location. Bengaluru. Okay, and the profession we have to define from here. In this case, state, here we will define profession. All right, we have another two nodes, C and D. We are going to define C and D. Here it is going to take the output of node B and here also going to take the output of node B, and this is going to be out, we will mention here as summary. You can correlate with our state execution in our previous video segment. Here also going to provide us the summary. Okay, finally we are going to create a router. Define router, which is going to take an input, right? So it should get some input, and then it will provide us the output. So what should be the input? Its input must be output of node B, and if state and location equals Bengaluru, return, I would say Bengaluru. Okay, else state or return, I'll say Chennai. Okay, so if the location is Bengaluru, we will be returning Bengaluru, or if the location is Chennai or not equal to Bengaluru, we are returning the Chennai. So all our functions or the nodes are ready. Unfortunately, we have created it in the tools area. We are going to create the necessary input and output schema here. From typing, import typed dictionary, then we have to create a class input underscore node underscore a, and it is going to accept a typed dictionary method. Here we are going to declare the data type is going to be a string, and the variable is schema variable is name, because here we are going to pass the name. Okay, and next we are going to give class input. So do we have any other input part? No, right? Only we have the output node B and summary. Output underscore node underscore B and typed dict. Here we will have name, profession and location. Name is going to be string, and profession is going to be string again. Location is also going to be a string. Perfect, we have created that part. And finally we are going to create summary, and that is going to be typed dictionary again, and here we will mention what should be the summary. Before we defining the summary, let us add one summary note as well here. Summary is going to be the summary node C is executed. Here we are going to define Chennai, then node D is going to be Bengaluru as it is, and the summary is going to be the summary node D is executed. We just want to know what is happening, that's it. And here we are going to define the summary schema. That's going to be name is equal to string, then profession is also a string, then location is also going to be a string, summary also going to be a string. Perfect. So we have three input output schema. Other than that, nothing is needed at this point. We have everything in place. Okay, now what else is needed here? We have state in place, we have tools in place, finally we have node is needed, right? State import. What are all the parameters do we need to import it? The first thing is input node A, next is going to be output node B, and the last is going to be summary. Okay, so that part is fine. So these all will be perfect. We forgot one thing, output node A, input node A, and class output node A, and here we need to define typed dictionary. Excellent. And here we need to define name string, and profession also going to be a string. Okay, everything is in place, and let's move this here. Okay, we added the comma. This part is complete. We will do one thing, and we will move this complete tools.py to nodes.py. My apologies for the last minute changes. In this we have everything in place, right? This tools separately we will create some Python functions and integrate in our interactive workflow. Let's forget about tool now. Now we have state, we have node. Now let's assemble the agent first. For that, from utils dot nodes import, here we have to do node A comma node B comma node C comma node D comma router. We have everything is in place. Next, from LangGraph dot graph import state graph and end from ipython dot display import display and image. Okay, now builder equal to also we need to import this state as well. Because we need to define the input and output, right? The state is going to be utils state. Excellent. Then the next part that we are going to do is state graph, and here input is going to be our input node A and output is equal to summary. Okay, then our node is ready. Let's create our workflow is ready. Let us create a node. Builder dot add underscore node. Here we are going to give A and node A, builder dot add underscore node B comma node B Similarly, we will copy paste everything as it is. C D C D. Okay. Next, builder dot add underscore edge. Here first we are going to create A to B, that is going to be the first edge. Then we are going to create a conditional edge here, builder dot add underscore conditional underscore edge. Here we are going to define first B, then we are going to define our router that we have already imported it here. Then we are going to create the conditions. First, Bengaluru, it should execute C. If Chennai, it should execute D. Excellent. Then last step is builder dot set underscore entry point. Here we are going to define node A is going to be our entry point. Last is graph equal to builder dot compile, and here we can define the debug is true or something, or whatever it is. Let's leave as it is. Let's open a notebook, agent underscore notebook dot ipynb, and we will copy the whole content to agent nb ipynb, and we will execute it. So I'm going to create I'm going to select our favorite Python 3.9 point something set. Let's execute it and see whether it is working as expected or not. Okay, there are some errors. Cannot import name display from IPython display. Why? Okay, it's a typo. Display conditional edge. What is that? Add conditional edges. That's okay. What else now? Okay, builder compile any option here, debug equal to true. Okay, so we have everything in place. Display, and inside that image, and inside that graph dot get graph, and it's going to be a method dot draw mermaid png. Now we will see the flowchart. Excellent. The Bengaluru and Chennai, it has been defined it here, right? So the final part which is missing here is an endpoint. Builder dot add edge C, and it's going to be end. Then builder dot add edge D, and it's going to be end. Perfect. Now if you look at it, we will be getting a proper workflow here, right? So I'm going to copy the same thing to our agent.py file. Let me do a Control A and Control V. Excellent. So agent.py is here, and I should make sure that I'll be installing this LangGraph and IPython. So here I'm going to mention LangGraph, IPython. What else do we need? Langchain. So our graph is properly plotted here. Then the same thing we have updated in the agent.py as well. Excellent. Then coming back to the last and final piece, Langgraph.json. In the Langgraph.json, it's going to be quite tricky stuff. Let's do dependencies. So we have to define the dependencies here, and it should be in the form of list, and there you can define /alpha graphs. The graph is going to be again a dictionary. It is having something called agent, the location of the agent, where it is /alpha/agent.py. Finally here we have to define the graph. Okay, and the environment file here is going to be .env. So our langgraph.json file is also ready. Now it's the right time to initialize our LangGraph. Let's save it. Then we are going to add it to the repository. Let's do a git pull freshly here. Then git add dot git commit -m initial commit git push. So we have committed everything to the repository. Let us look at it here, whether it is being visible. So everything has been here. Excellent. The next step is we are going to open the LangGraph Studio. Now we are going to open a project. Let's click select, and here ngdm, and we will open alpha, or we will go to ngdm, and let us look at it. Docker is not running. That's fine. We will create a Docker desktop is up and running. Now we will do a retry. It is trying to open the thing. In this case, it is pulling the Langchain LangGraph. If you look at it, the necessary packages are being installed. The Docker container is trying to get executed. Are we getting any error or something? No. So far so good. Okay, our LangGraph agent is ready. Now we will say something called let's say Sriya, and I will submit it. And it was started from name, the first input, then it went to name and profession to ID, then it went to the state here, location Bengaluru, name and profession ID, then it executed the graph C here. Okay, and we need to change something, right? Or rather, in this way you will understand in a better manner. We have given name just input, then here name and profession, then we have given name, profession, location as the B's input, then in the C we have added the summary to Chennai. Why it is executed Z, we need to check the code first. Okay, because it was Bengaluru, right? So we need to adjust the file again. We will go to the nodes in this. C is Chennai and here D is Bengaluru. And how did we define the router part here? Agent.py. C is Bengaluru, D is Chennai, C is Chennai, and D is going to be D is going to be Bangalore. So we need to interchange here. Okay, I'll add this again. Git add, commit, push. Let's look at it. What is going to happen here in the NGDM? Bengaluru and C is Chennai, D is Bengaluru, and if I mention Sriyan, it's going to get executed in this way. So which one is being executed? C. Not C, D is getting executed. Summary node D is executed. Perfect. Now if I change here to the location Chennai, and if I commit this, commit, push, and then I will come to the LangGraph. Alright, now I'm going to mention here again Sriyan. So what will happen here? It is Chennai. This time it executed through C. So this way we can visualize the thing, and in our next video, in this each node we will be adding separate tools. As I promised, we have created a dedicated nodes here, and we assembled the agents here, and we created the metadata using LangGraph here. I hope it is clean and neat, and the necessary modules are defined in the requirement.txt file. So overall what is happening is, as soon as we commit this particular folder or repository, we are mapping this repository to the Langchain Studio or LangGraph Studio. As soon as we commit this code to the repository, we are sharing the particular repository path or the folder path to the LangGraph Studio. It will be pulling the necessary container images and clone the repository, and then it will be running the code on top of that container, so that we will be getting a proper API. Through the API we can interact it and we can perform various exercises. We will be exploring various tools. We have created certain functions like a SQL database querying and all. Those agent functions will be deploying here, and we will be interacting it with various third-party applications, so that our chatbot would be looking quite nice. Then we will export it and deploy a multi-agent AI. This way we can make it much more fruitful or much more plain and simple manner. That's it for now, and wishing you a great rest of the day. And this is Melvin Satishan signing off. See you later. Thank you.